In section 1.4, we're going to continue solving equations. Now we're going to look at a special type of equation, an absolute value equation. So let's take a look at the top of the page here. An absolute value equation is an equation that contains an absolute value. So let's kind of remember what absolute value is. So I've got some extra room here off to the side. Let's review this. So remember the absolute value here. If I say the absolute value of 5, the absolute value is asking you how far away is 5 from 0. So on a number line, if I were to draw 5 here, okay, we can see that that's 5 units from 0. 1, 2, 3, 4, 5 units from 0. So the absolute value of 5 is 5. Similarly, the absolute value of negative 5 is, well, let's check. Negative 5, if we draw that on our number line, negative 5 is also 5 units from 0. So the absolute value of negative 5 is also 5. So we get the same thing. Whether we're taking the absolute value of 5 or negative 5, we get 5. A lot of people remember the shortcut is that absolute value is always just the positive version. That's going to be true. The absolute value will always be positive because it's a distance. So it doesn't matter if we're taking the absolute value of a negative or a positive. It's the same number of units from 0, so it's always going to be positive. So absolute value of 5 is 5, absolute value of negative 5 is 5. Okay? What that means for us in terms of an equation is that we're going to have two different solutions because we get the same thing, we get 5, when we plug in negative 5 or 5 into the absolute value. Okay? So we're going to get the same thing either way. So let's take a look at a little equation here, the absolute value of x equals 5. And I want to know what is x? What could x be? Okay, think about it like this. I know we just figured out that x could be 5 or negative 5. Okay, so x has two solutions. X could be 5 or negative 5. Okay, so this is going to be a key part of absolute value equations. All right, absolute value equations have two solutions. Absolute value equations typically have two solutions. We'll talk about a few cases where it might not have two solutions, but typically an absolute value equation is going to have two solutions. Okay? In order to get two solutions, what we're going to do is we're going to break this up and make two equations. All right? We're going to get two solutions by making two equations. So let's go ahead and try this in the first example. So we have our first example. It's an absolute value equation. In order to make two new equations, I'm going to split this up. Or in order to get two solutions, I'm going to split this up and write two equations. So I drew those two lines to represent my two equations. My two equations will no longer have absolute value. I'm going to write two linear equations, all right? So the first equation is to pretty much write it the exact same, but without the absolute value, okay? I'm going to draw a line down the middle, and then I'm going to write a second equation. My second equation now, because we know that the absolute value, right, we know, remember when we talked about the absolute value, how do we get 5? It could be 5 or negative 5. In this case, x minus 4 could be 6, or x minus 4 could be negative 6. So just to clarify here, when you make your two equations, the first one stays the same. The second one, it becomes negative. Notice how the x minus 4, what was in the absolute value, didn't change. It was just what the absolute value was equal to that changed. Here it stayed as 6. Here it changed to negative 6. Again, the absolute value stayed the same as x minus 4. Now I'm going to solve both of these separately. So I'll solve the first one by adding 4 to both sides. So I'll get x equals 10. And I'll solve the other one also by adding 4 to both sides. But this time it's negative 6 plus 4. So that's x equals negative 2. So like I said, two solutions here for my absolute value equation. Let's try the same thing on the next one. So again, we have an absolute value equation. Anytime you see those absolute values, so this is something that kind of needs to get into your head here. Anytime you see those absolute values, you need to think, okay, there's going to be two equations, and immediately start by breaking it up, drawing your two lines here so we can write our two equations. So now let's write our two equations. Remember, the x minus 1 stays the same in both of them. We want x minus 1 equals 4 for the first one, and x minus 1 equals negative 4 for the second one. It doesn't matter what order you write these equations in. All right, then we'll go ahead and solve both of these. So I'll add the 1 to both sides, and I'll get x equals 5. Here, I'll add the 1 to both sides, and I'll get x equals -3. Let's take a look at example C. So example C is actually a special case. It doesn't look like it at first. At first I see the absolute value, so a part of me is like, okay, well, she said absolute value, write your two equations, right? But I'm actually gonna say no here. I'm gonna undo that. There's something special about this problem that I want you guys to make sure you identify when it happens, okay? So we talked a little bit earlier about how absolute value is a distance. So the absolute value cannot be negative because it's a distance from 0. Even if you're going left, it's still a positive distance. You might be going left 5 or left 6 or left 10. It's still a positive distance. So in other words, just to kind of clarify, the absolute value can never be negative. Well, look at what we have here. We have the absolute value, and it doesn't honestly even really matter what this is. I'm going to cross it off. All I know is that it is an absolute value. It doesn't matter what it is. We know that we have an absolute value, and it's equal to a negative, and we cannot have that. In other words, this will never work. My answer is actually no solution. We don't solve it at all, and that's something you have to make sure you can identify. So let's write that down just so we remember it, but it's something you're going to have to practice and kind of keep in your head. Absolute value cannot, I'm going to put it in all caps and underline it, be negative. So if you see an absolute value problem equal to a negative number, automatically you're going to say, okay, it's no solution, I'm going to stop. Well, let's take a look at example 2 then. Hey, look, we have an absolute value and it's equal to a negative, so should we stop? All right, well, here's the next step, all right? Here's the next trick. We have an absolute value and it is equal to a negative. The issue here is that the absolute value isn't by itself. So the absolute value itself has to equal a negative, and it's not by itself. So we don't actually know what the absolute value is equal to because it's not by itself. So first we have to isolate the absolute value by getting rid of anything on the outside. What's on the outside is -10. How do we get rid of -10? We do the inverse, which is add 10 to both sides, always to both sides. Now the absolute value, 3x plus 9, is by itself. But now it's equal to a positive, so we actually can solve this one. So be careful there. So now let's go ahead and solve this. I'll write my two equations. My two equations, remember the 3x plus 9 stays the same. For my first equation, it's equal to 6. And then the 3x plus 9 is equal to -6 for the second equation. And now we'll solve this. I'll start on the left side, subtracting 9 from both sides, to get 3x equals -3, and then I'll divide by 3 on both sides, and I'll get x equals -1. For the other one, I'll go ahead and subtract 9 on both sides there too. I'll get 3x equals -15. I'll divide by 3, always on both sides, and get x equals -5. So they're my two solutions. So the key difference between example 1 and example 2 here is that first we have to isolate the absolute value. We have to get the absolute value by itself first, and then we can solve it. So let's try that same thing in example B. I need to first get the absolute value by itself, which means I'm going to need to get rid of that +5. To get rid of that +5, I'll subtract 5 on both sides. Still have the absolute value of x minus 2, but now it's equal to 4. 4 is positive, so I can keep going. If it was negative, I would stop and say no solution. But I'll keep going. I'll write my two equations. My two equations should be, remember the x minus 2 stays the same, and in the first equation it should equal 4. In the second equation, x minus 2 should equal -4. And then let's go ahead and solve those. Add 2 to both sides to get x equals 6 for the first answer. Add 2 to both sides over here to get x equals -2 as the second answer. All right, we're going to keep going, and now we're going to solve absolute value equations that have two absolute values. So our process is going to be very similar. There's still an absolute value, so I still have to write two equations. So I'm still going to write two equations. And just like we did before, one of my equations will be equal to the positive and one will be equal to the negative. I'm going to pick one of these to change. I'm just always going to go with the second one. It's usually easier. So the 3x minus 4 will stay the same. In my first equation, it'll be equal to x. And in my second equation, 3x minus 4 will be equal to negative x. And then I'll go ahead and solve both of those. So in this case, I need to get the x's on the same side, so I'll subtract the 3x to get it combined here. So it's negative 4 equals negative 2x, because we had to get the x's on the same side, and then I'll divide by negative 2. So I'll get 2 equals x. Let's see, on this side, on the other one, I'll go ahead and subtract negative 3x again. So now I have negative 4 equals negative 4x this time. And I'll divide by that negative 4, so it cancels. And then on the other side, it'll become 1. Negative 4 divided by negative 4 is 1. So x is 1 and x is 2. Let's try another one of those. This one gets a little bit more complicated because now I don't just have an x on this side. I actually have a full-on expression. So I'm still going to start by breaking this up and making two examples, or two new equations. My first equation, everything stays the same, except for the absolute values are gone. X plus 8 equals 2x plus 1. Easy enough. In the second equation, I leave the first expression, x plus 8. On the second one, I have to make it negative. Now, hopefully what's going through your head is, well, what do I make negative, the 2x or the 1? The answer is both. You switch the signs for both of them. If they were already negative, you would make them positive, okay? So because it's positive 2x and plus 1, I'm going to make it negative 2x and minus 1. Whatever the signs are, I switch them. Again, to clarify, the x plus 8 stays the same the whole time. So let's start solving here. I need to get the x's on the same side, so I'll subtract the x here. So now I have 8 equals x plus 1. I'll subtract the 1 to get rid of that, so I have, oh, that's not how you subtract. How about 7 equals x? And same thing on the other side. I'll go ahead and add the 2x. So that's 3x plus 8 equals negative 1, because the negative's still there. Let's subtract the 8 to get 3x equals negative 9. And then I'll go ahead and divide by 3, so x equals negative 3. All right, let's turn the page. We're going to talk about something called an extraneous solution. It's going to kind of sound like it was made up, but it's real, I promise you. An extraneous solution is an apparent solution that must be rejected. So basically, it's a solution that doesn't check out. So let's write that down. It's a solution that, and I'm going to put this in all caps and underline it, doesn't check out. So that means the only way we're going to find extraneous solutions is to check our answers. And if they don't work when we check it, then it's an extraneous solution that is not actually a solution, okay? If they do work, then it checks out and we're good to go, all right? So back in, the first couple sections of this chapter, we were checking our work. And it's always important to check your work, but now it becomes crucial. You have to check these to see if there's any extraneous solutions. So let's take a look at this example. We're going to solve it just like normal, and then we're going to check our solutions. Solving this problem, this first problem, just like normal, means writing two equations because it's an absolute value. My first equation will be 2x plus 12 equals 4x. My second equation would be 2x plus 12 equals negative 4x. So nothing new so far. And now let's go ahead and solve these. Let's get the 2x on the other side by subtracting that. So I have 12 equals 2x. Let's divide both sides by 2, and we'll get 6 equals x. So my first answer is 6. Before I check that, I'm going to solve for the other one, and then I'll check them both at the same time. So here I'll subtract 2x. This time I'll have 12 equals negative 6x. And then I'll divide by negative 6. So I'll get negative 2 equals x. And then I'm going to go ahead and check these. So I've got some space down here. I'm going to do my check. To do my check, I have to go up to the very original problem. So it's the absolute value of 2 times x, in this case it's 6, plus 12 equals 4 times 6. So let's solve that. Let's solve what's in here first. 2 times 6 is 12, plus 12, so that's the absolute value of 24. 4 times 6 is 24, and the absolute value of 24 does equal 24, so that checks out. So the first one checks out. X equals 6 is one of my answers. Let's check the other one. So it'll be the absolute value of 2 times negative 2 plus 12 equals 4 times negative 2. This is negative 4 plus 12 is 8. So it's the absolute value of 8 equals 4 times negative 2 is negative 8. We talked about this earlier. Can the absolute value ever equal a negative? It's a hard no. We cannot. We cannot have the absolute value equal to a negative. So automatically, I know that this solution does not work because we have the absolute value equal to a negative, and that's a big no. So my only solution here would be x equals 6. If you tell me that x equals negative 2 is a solution, you're wrong. It's an extraneous solution. Let's try that same thing again. We're going to solve it and then check our answers. So to solve this, I'll make my 2 equations. My first equation will be x plus 6 equals 2x, and my second equation will be x plus 6 equals negative 2x. I'll solve the first one by subtracting x on both sides to get 6 equals x. And I'll go ahead and solve the other one. I'll subtract x on both sides. This time it doesn't work out quite as nicely. I end up with 6 equals negative 3x. So I'll have to divide by negative 3, and I'll get negative 2 equals x. And just like I did before, I'll go ahead and do my check. When I plug the first one in, it's 6 plus 6 equals 2 times 6. That's the absolute value of 12 equals 12. That is true, so the first one checks out. Let's try the second one. It's negative 2 plus 6. That equals 2 times negative 2. That's the absolute value of 4 equals negative 4. Uh-oh, red flag. We can't have the absolute value equal to a negative, so this one does not check out, which means my only solution is x equals 6. It might not always be one solution. It could be both of them check out. It could be one of them checks out. It could be neither of them check out. So you have to check both of them. Even if the first one works, you can't just be like, oh, the second one must not work. You have to check them both. All right, let's keep going. We're going to solve absolute value equations with 2 absolute values, just like we did before, but now we're going to check our answers to make sure that we don't get an extraneous solution. Something kind of interesting is going to happen on these two, so you'll see that in a second. So I'll start by making my 2 equations. Remember, the x plus 5 stays the same, and in the first one, so does the x plus 11. In the second one, the x plus 5 stays the same, but the x plus 11, remember, everything will switch signs, so it'll become negative x minus 11. All right, watch as I solve this. I need to get the x's on the same side, so I'll subtract x, and I'll subtract x. What happens is it actually cancels on both sides, and I end up with just 5 equals 11. Does 5 equal 11? No. So before we would stop and say no solution. Well, there's no solution on that side, but let's check to see if there's a solution on the other side. So here, I'll actually add the negative x, so I'll add x. And then when I add these 2 x's, they don't cancel, and it becomes 2x plus 5 equals negative 11. It looks like I will have a solution here. So I'll subtract the 5. I'll get 2x equals negative 16. I'll divide by 2 and get x equals -8. Let's do a quick check to make sure that that one works. So off to the side here, I'll do my check. That's -8 plus 5. Absolute value of -8 plus 5 equals the absolute value of -8 plus 11. That's the absolute value of -3 equals the absolute value of 3. Both of these become 3, so 3 does equal 3, and it checks out. Let's try the last example here. Again, I'll make my two equations. On the left side, I'll have 2 plus x equals x minus 8. On the right side, I'll have 2 plus x equals, switch both signs, -x plus 8. Don't forget to switch both signs. That's a key part here. And I'll solve this, and actually the same thing's going to happen. I'll subtract the x from both sides, and it'll cancel on both sides. So I'll end up with 2 equals -8. Well, that's not true, so let's move on to the next one. Here I'll add x to both sides, and it doesn't cancel, so that's good. So it'll be 2 plus 2x equals 8. And then I'll go ahead and solve that. I'll subtract 2 on both sides. And then I'll go ahead and divide by 2 on both sides. And I'll get x equals 3. Really quick, let's check that. So that'll be 2 plus 3 equals 3 minus 8. That's the absolute value of 5 equals the absolute value of -5. So that's 5 equals 5. It checks out. So that's solving absolute value equations. There's a lot in this lesson, so if you have to, go back and rewatch any part or try some of the examples again. The biggest thing with absolute value is making sure you're making those 2 new equations to solve it.